Hello, algebraic reasoning. Today we're going to be talking about some more advanced multiplication properties of exponents. So to recap, the first question is saying multiplying exponents with the same base, what do you really do? So this is saying like if you have x to the third times x squared, what actually goes on? And we said that means you're going to add and you'll get x to the fifth. So you really add the exponents. And the next one says the negative exponents are turned positive when you flip it over the, so this is saying, well, what happens when you have x to the negative 3? Well, we said that's the same thing as saying 1 over x cubed. So I assume that it means you're going to flip over the division sign. Okay. Every number raised, and this shouldn't be every number that such that if the number is x, x does not equal 0, raised to 0 power is 1, right? We said if you see something like x to the 0, that's equal to 1. 5 to the 0, that's equal to 1. Okay. You can use the properties of exponents to simplify a power raised to a power or a product raised to a power. You can use repeated multiplication to simplify a power raised to a power. Okay, so what this is saying is that given x to the fifth squared, this is where we have new material, x to the fifth squared means what? Well, it means you're squaring x to the fifth. So this means x to the fifth times x to the fifth. And so, of course, x to the fifth means if we say what the bases are the same, then we can add the exponents. So this would be x to the 10th. Now, I don't think the point gets driven home with just squared. So let's say instead we raise it to, let's say, the 6. So this means that we're going to have x to the fifth times 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 x to the fifth for a total of 6, which means we're going to have what? X to the 5 plus 5 plus 5 plus 5 plus 5 plus 5. And what is a simplified way of adding 6 groups of 5s, right? Well, that's just 6 times 5, or 30. If you don't believe me, type 5 plus 5 plus 5 plus 5 plus 5 plus 5 into the calculator and see that you will get 30. Okay? So what does this illustrate? Well, this illustrates the fact that when you raise to another power, you multiply. That's the rule we're going to be using today. So let's move on. So here we see it. We see if we do 5 to the 4 squared, it means 5 to the 4 times 2, which is 5 to the 8th. And you can get complicated with fractions, but you can see it's just the same rule. This is just 3 over 2 times 3 over 1, which is 9 over 2 for the exponent. We see some more examples here and here. Let's move on. So try this on your own. Go ahead, pause the video if you haven't done so already, and try this on your own. And so what is b to the third raised to the fifth? It's the same thing as 3 times 5, or b to the 15th. What is a simplified version of x to the 2/3 times 3/5? That is the same thing as saying x to the 2/3 times 3/5. And then you can see that this is cooked up so that you can clearly see the 3's will cancel out. So this will be x to the 2/5. What is the simplified form of, I'm going to rewrite this just to be clear, x to the negative 2 times x to the 4th raised to the negative 3. The way they wrote that was kind of weird. So my advice here, well, let's clean this up first. And notice we're still actually following PEMDAS. That's the cool thing about this. You're always doing PEMDAS. So this is x to the negative 2 times x to the negative 12. Notice that all I did was multiply 4 times negative 3 and get negative 12. Okay. Well, now that the bases are the same, we know the rule is that we add the exponents. And this is going to give me x to the negative 14, or if you prefer, 1 over x to the 14th. And there's your answer. which expression represents the area of a square. So this is kind of cool because it's using some of the properties that you've learned in the past. So we know that squares have equal sides. So this is 4x to the 5th here. We also know that area is length times width, so we just multiply them together. So it's 4x to the 5th times 4x to the 5th. And this will get you the answer, which is 4 times 4 is 16. X to the 5th times x to the 5th. We know that when we multiply, we add the exponents. So it's 5 plus 5, which is 16x to the 10th. Now, some of y'all will be like, well, okay, that's true, but the section is discussing what happens with you have exponents to exponents. Notice that what I did there is the same thing as saying this right here is the same thing as saying 4x to the 5th squared. So if you wanted to, instead of doing it the way that I did originally, you could distribute this 2 to both. In other words, you're doing 4 squared times x to the 5th squared, which becomes what? 4 squared is 16, x to the 5th squared just means you multiply the exponents. 5 times 2 is 10, and you get the same answer. So don't limit their thought process to just one way. You really should be able to tackle problems multiple ways, and that's how you know you're doing it right. So that's what this is here stressing, which is that if you have multiple values, so I'm making something up here, to the 4th, now let's spice it up. Let's go like this. This is equivalent to a to the 4th, b to the 2 times 4, which is 8, and c to the 3 times 4, which is 12, which means every exponent is affected by it. And you can see that in these examples. Okay, it says raise each factor to the power to multiply. Okay, what is the simplified form of this? Okay, so let me rewrite it. We have b to the 1/3 times 2, ab to the negative 1/2 raised to the 4th, and this becomes b to the 1/3 times 2 to the 4th, a to the 4th, times b to the negative 2. And if you're wondering how I got negative 2, I just did 4 times negative 1/2, which gives me negative 2. And then we'll clean it up. So if you struggle with this, what you want to do is put it in order. So we notice I put the numbers together, the a's together, the b's together, okay? And so 2 to the 4th is 16, a to the 4th is a to the 4th, and with the b, we're going to do 1/3 plus negative 2. Now, when we do the 1/3 plus negative 2, we have to remember that with fractions, we have to get a common denominator. So the negative 2 becomes negative 2 over 1, and I'm going to use that color. Green again. Well, I think I've used all the colors brown. Okay, multiply both the top and bottom by 3 to get rid of the fraction. So we have 1/3 plus negative 6 over 3, which is negative 5/3. So this becomes 16 a to the 4th, b to the negative 5/3. What you will see is that they'll say you can't have negative exponents, or they don't want negative exponents. Sometimes they'll say that in the answer choice. So this is the answer. Okay. So again, don't let the fractions confuse you. You just get common denominators, put them together, and you get your answer. Let's look at the next one. So this is n to the 1/2, 10, and this is going to be 4m, and it's a negative 2/3 raised to the 3rd. So how do we go about doing this? Well, again, it's going to multiply. So what's half of 10? That's 5. This 3 goes as the exponent to all of these. So this is going to become times 4 to the 3rd, m to the 3rd, and n is going to be negative 2/3 times 3, or 3 over 1. You can see that the 3's will cancel out, so we're going to be left with n to the 5th times 4 to the 3rd, m cubed, and this is going to be n to the negative 2. So now we'll organize it. So we have 4 to the 3rd, m cubed, n to the 5 plus negative 2. And the question in your head should be, well, maybe one of the questions that emerges, well, why is it 5 plus negative 2? Well, because we said when we multiply, we add the exponents, and all of these are being multiplied, right? I'm not writing the multiplication symbol, but they're all being multiplied together. So this is going to leave me with 4 to the third, which is 4 times 4, which is 16. 16 times 4 is 64. M cubed, n cubed. And there's an answer. Okay, last question. The volume for this, the formula for the volume of a sphere is v equals 4/3 pi r cubed, where r is the radius. What is the volume of a cube with a radius of 10 squared millimeters? So we're going to say v is 4/3 pi r cubed, just to make life a little clearer. So v equals 4/3 pi. R is 10 squared cubed. So this is going to leave me with v equals 4/3 pi 10 to the 6, because we multiply 2 times 3 and get 6. And this is going to leave me with v equals 4 times 10 to the 6 over 3 pi. And I'm going to go ahead and just say that that's acceptable. I mean, if you wanted to go a little further, you could, but it's not really going to help you out that much to see the actual value because it's going to be ugly. However, if you want to, I typed it in for you, so you're going to be left with, if you want to write it this way, that's fine. 1, and we have what? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6.33 repeating pi. And that would be your answer. Okay, that's pretty much it. So, not too bad, even when they look ugly, they're really not that ugly. So I hope this makes sense, and I'll find you all in the next math video.